We hold these truths to be self-evident. Wait a minute, which truths? I was getting to that. Wait, self-evident, so, okay, maybe something like 2 plus 2 equals 4? Yes, that does seem rather self-evident. Yippee! We hold these truths to be self-evident. Thank you, thank you, thank you. When the Founding Fathers wrote the Declaration of Independence, they were using terms like equal and freedom, and we've got particular symbols that we use when we're talking about truth as well. So I want to discuss all these and tell you what they mean. You've seen the first one a lot, so that means equals. And there are plenty of good examples of how this works. So something like the astronaut saying 2 plus 2 equals 4, or something just as simple as 7 equals 7. The next symbol is greater than, and that means that the big number is going to be on the left, so something like 12 is greater than 2, or 0 is greater than negative 3. Then we've got a less than symbol, so the big number is going to be on the right. Something like 99 is less than 100, or negative 7 is less than negative 1. But you may not have seen these symbols before, where we combine these symbols with equals. So our next one is greater than, or equal to. So you can say something like 8 is greater than or equal to 5, because 8 is bigger than 5. But you can also say 3 is greater than or equal to 3, because 3 is equal to 3. Same idea with our next symbol. That means less than or equal to. So I can say something like 2 is less than or equal to 3.5, because 2 is less than 3.5. But I can also say 3.5 is less than or equal to 3.5, because they're equal. So let's look at some mathematical statements, which we have here, and some values that we're going to substitute in, and we're going to try and figure out true or false. Here we go. We're going to take v equals 5 and put it into this statement. Well, when I do that, what I get is 5 plus 7 equals 12. Oh, that's true. Let's put a T for true right there. Let's try something that would make that false. So, I don't know, let's try v equals 2. Now, if I take that 2 and plug it in here, what I get is 2 plus 7 equals 12. That's not true. That's false. And that's what I was trying to do over here. Whatever I got in this column, true or false, I'm trying to make it the opposite over here. So since I got true here, I want false here. Let's do that again. So let's look at the 5g is greater than or equal to 25. And I want to plug in g equals 6. Let's do it. 5 times 6 is greater than or equal to 25. Well, that's true, because 5 times 6 is 30, and that's bigger than 25. Yay, it's true. So let's try something to make it false. And this might take a little bit of doing here. Fortunately, there are lots of choices. I want something so that when I multiply by 5, I'm not bigger than 25. So maybe we could try something like g equals 4. So 5 times 4. Is that greater than or equal to 25? No, that's a false statement. So we were able to turn a true statement when g equals 6 to a false statement when g equals 4. And that's really all we're trying to do here. We're trying to figure out which values make things true and which values make things false.